Thank you very much. Good afternoon. Last one, you're almost done, you're almost there. And it won't be that long, don't worry. I'm Oliver. I work at Tesco since a year, just about a year I've done there. I've done 9 years at Amazon beforehand. And background, I've studied economics, so a million miles away from what you do. I've done fluffy marketing, colorful advertising stuff. And then kind of that wasn't right, and I've done a PhD in statistics. Then did my time in Amazon, lots of operations stuff, as in fulfillment centers, warehouses, all these things. Did supply chain at Amazon, and now do, whatever that is, fulfillment planning and transportation. I'm still not quite sure what I'm meant to be doing. I think it's that. No, don't worry, I don't play with toys all the time. I make families happy every day. That's my job, I think. And it's not easy to do that. If you, I don't know, I don't think many of you will have kids, but you will know kids. Yeah, there we go, super. But if you look in the eyes of a little child with a toy, then you know that is excitement, that is cool. And then you know why you're doing your job. But it's not that straightforward. You will know that it isn't easy at all times to make little kids very happy. Neither is easy to make adults very happy at times. Yeah? And where am I clicking here? Where does this? There we go. So and the first thing people think about is with Tesco, is loads of stores with stuff inside. Yeah? And it's also online, and this kind of multi-channel, how do people think about buying nowadays is, well, you used to go in a shop, you go weekly shopping on a Saturday and the whole car full of stuff. But that's not anymore like that at all. You buy stuff online, you run out of your favorite booze on a Saturday night, you've got people around, you just order it in. You just get someone to deliver it to you because you can't leave your people at home, would be even worse, to your house. And that's what you do. You don't shop in the classical ways anymore. And behind those two blobs of what was in store and what was online, of course, sits an awful lot of work to make customers happy. For example, these are just a few examples. How do you get the stuff from somewhere in Asia, from a farm in Oxfordshire, from anywhere into every single store? Into every single house? How do you get this planning done? How do you have the technology behind this stuff? The sad thing is, the customers really don't care how you do that. They come into a shop looks great, and there's loads of these shops around, over 3,000 in Tesco, and that's what they worry about. Yeah? In London, you're never further away than 5 minutes from a Tesco store, and what they worry about is, do you have it, what I want? Do you have if you want something specific? Or is it inspirational? I don't know what I'm going to have for dinner tonight. I'm looking for some inspiration because I really don't know. I literally don't know. How much is it going to cost? It's quite interesting that cost is, of course, a differentiating factor, but you can see cost very well. It's an ever more transparent market, and a cucumber is, in most cases, is a cucumber, tomato is a tomato. There's quality difference, but in the end, how much does it cost? You want to know how you pay for that stuff. Yeah? What if you get stuff delivered? I'm not in. Yeah, that's fine. I'm hardly ever in, and that's fine if I get an envelope or Royal Mail or so delivered, a little parcels from Amazon. That's great. If you get a sofa delivered, that's not that easy. Yeah? So in the end, what is it? What makes it different? Why is analytical stuff so important to differentiate someone like Tesco, and why is it a good problem to work on? Well, as I said, price is completely visible. You can look up anything everywhere online. If you buy this clicker, you can just look on 20 different websites, or even on one comparison website will tell you exactly what it costs. Loyalty, really, I want this clicker, I don't care who delivers it. And that drives competition. So the three things, in my view, which are making a difference, which are cool to work on, is how are you going to get faster, how are you get more convenient with what we do, and how do you get it very cheaply done? Because cost matters, because price matters, and in the end, it's either you get it very fast, you get it at high convenience, or you get it very cheap. So those three things matter, unless you worry about the brand, of course, and of course, there's all that kind of stuff. When we talk about those as an example, then there are problems you need to solve through analytics. All of those you just can't make them up. And Tesco is on this journey from being a grocer to almost, I would also say, be a technology company who happens to sell grocery. Like Amazon is a technology company who happens to sell stuff. Google is a technology company who happens to do advertising very well. Yeah. So these are the problems I worry about every day. And as a few examples, I just want to take some time and describe what I'm doing. It's a classical one of a store. Stores, if I'm saying the big weekly shop is out of the way, goes away and people don't do that often anymore, what's actually the right size for a store? How are they still the big superstores? You go in and you get lost and you never know where entrance is or how to get back out and find stuff. Is it really that important to have 20 different ketchup varieties? What's the right thing? Is it the small things in town where you can get I don't know how many hundreds or thousands of top lines of everything, you get one ketchup, but you don't get anything special. If you want something specific, it might not be there. You won't have a great selection of craft beers or so. But look, this is stuff you can make up, or you go about it in a very technical, analytical way, and then it becomes great fun, because the answer is there. We are increasingly knowing the answer. It's different by customer, of course, but in the large groups of customers, this thing is shifting around. How do they look? And how will the store look? How wide is an aisle? Yeah? How do you present a tomato best? Where do you put it? Up here, down there, over there? What is your snail through a store? Classic, these examples have been around, 100 years or so, when people thought about the first stores and supermarkets where they thought about if I put something on eye high. Lots of that stuff is basics. We just happen to have billions of data points to make sense out of it. We are testing machines who drive past a shelf every minute and take a picture of the shelf and make a buying decision to replenish the ketchup. That's cool. That's data. That's how you go about these kind of stuff. Network optimization, another example of look, if you've got 3,000 shops, you have to get stuff from A to B. How does that look? How do you get to a customer as fast as possible? How do you decide where to place new buildings so that you've got the fastest routes, if speed matters, if convenience matters, if you don't want to run unnecessary amount of mileage with thousands of trucks every day? They are interesting questions in itself, where to place a building. How does it look inside a building, for example? What's in the building? The inventory holding. What's in a shop, as I said, the machine taking a picture and automatically replenishment of the stuff you're selling, and how does the shelf look? Do you need to do anything? How do you forecast demand? Forecasting in itself, you can fill your whole lifetime on figuring that one out. Yeah. That by definition forecasts are wrong, but they're an extremely analytical field. As with all of this stuff, it doesn't matter whether you call it OR or statistics or math or astrophysics. It doesn't matter. The people who have got a background similar to this will find their way around forecasting. It's just another version of formulas and large data and how to go about it. Let's have a look at inside a building, how they look. This is a picture of a brand new building. We just open or just redesigned from the inside, and you see this endless corridor. And to the left and right you see shelves. This is a building, it's pretty much a large store, if you like, but just inside, but without any customers. You optimize them in a very different way. A store itself, as I said, you optimize how people run around the shop, and to get inspiration for their cooking. Inside, when you don't have customers, you make that look very, very different. And that's how they look. And by the sheer scale of it, the fact that you can't see the end of it will tell you that there is math involved, there's large amount of data involved controlling these environments. That run you see there, there's 3 more of those in parallel, and they're on 4 different levels. Yeah, you can easily store 400,000 different items in there, different type of items and millions of items at any time, and controlling that in itself, knowing where to put these items so you can get them out in the most efficient way is a great analytical problem, and all it takes is some hunger and appetite for analytics and for handling large data. That's a view on sortation. This is a very classical sortation, which is, I think this element here sorts into, I think, 300 different stores, where the stuff we are picking in these spaces is diverted into those. Every single cage there is a different store. How do you do that in the most efficient way? How do you route the cages then into a store? In which order? Classical transportation problems, as an example. So there are just a few examples, a couple more perhaps. Automation versus not so much automation. You can automate an awful lot. You can automate the whole replenishment of stores through machines, through robots. All of that is available and tested and works very well. Costs much more, but it still is it's a very, very highly efficient, very productive thing to do. Or do you just go about it with low capital investment in a much cheaper way, with a lower productivity, but again, you don't have so much outset cost at the front of it. And for every single product, that's different. And again, it's just another example. Waste reduction, when we talk about the whole chain, the amount of food waste in a retailer, or in any retailer, is horrendous, and Tesco is actually quite at the forefront, leading the effort to have no food waste, nothing safe to consume will be wasted. We'll go somewhere where we can make use out of it. But the concept of waste is so complex in itself. Food waste, or anything which is perishable, it's not going to be a tin of beans. That's difficult to have it going off because you're selling loads of them and they last an awful long time. But pre-packed mango slices, which have a shelf life of 2, 3, 4 days or so, and cost you £3, that's not that easy. You don't want to have many of those going too long on a shelf. You can't squish them. They're very fragile. Raspberries, that kind of stuff, very difficult to handle. They're cool problems. One of them is frozen, one of them is fresh, some stuff is ambient. What about flowers? Yeah, how do you ship flowers to a door or just on time for someone's birthday without any damage to them? All this kind of stuff is hugely complex, and most of it is something you can solve with analytical tools. Look at transportation. As I said in the first slide, it says I do some stuff with transportation. How do I offer a 1-hour delivery slot if you buy your groceries online for the 3 different temperature zones: fresh, frozen, ambient, some general merchandise stuff, a phone, I don't know, and a jumper, some clothing? How do you get that stuff to someone's house, and how do you even do the decision on when you could be there? So think about you do your shopping online, you buy those things, some stuff for the next couple of days to eat, a jumper, whatever. When the moment you buy it, we'll have to offer you a selection of 1-hour slots. Could be a 4-hour slot as well, there's different options, but say it's all a 1-hour slot. How do you pick, how do I offer which 1-hour slot you can pick? Well, first of all, I need to know where you live, and I need to know where all the vans which are delivering this stuff are so far from all the previous orders I've taken. And then I have to calculate from each van which there is, can I get to you on time? Depending on whether you live ground floor or high-rise 16th floor without a lift or so, depending on how many trays worth of food you have, if you just one item, if you've done a weekly shop, can I park easily? and drive back to the next customer after that. And I have to make that in any combination for all the vans I've running in the proximity and in the area where you are. And I have to do that in under 1 second, because you're not going to sit in front of that website and wait an awful longer until I show you which slots I can offer you for the next few days. That in itself is a beautiful optimization problem. It's a math problem. It's nothing else. There is an exacting solution to it, of course, a great optimization problem. You just take a few days to calculate that one. So you have to develop some clever heuristics to find that solution. You have beautifully written code, because you need to do this thousands and tens of thousands of times a minute. You have to be very, very stable. If your shop closes down because that stuff doesn't work, that's not very good. You have to have very good hardware, as in great servers. You have to get good architecture, so software architecture, machine architecture. You have to have people who are understanding the end-to-end problem, who can help you design how to deal with this stuff. And you need people who are then implementing it and working with hundreds of stores to utilize your new tool, for example. And then suddenly you see how many lights we can shine onto that simple problem in itself. This highly theoretical, straight out of university paper questions in there. There's coding, engineering, software engineering in there. There's architecture, there's physical hardware in there. There's project management. All of that is in the bucket of an interesting use case of what we call analytics, basically. And whether you call it OR or whatever, is this kind of stuff. Yeah. So what else do we have? Tracking predictive messaging to the customer on the same journey. So once you're on your journey we've offered the slot, you picked the slot, there you go, van comes tomorrow between 3 and 4 o'clock. You can follow, or you should be, not right now, but again, you should be able to follow where your vehicle is. You should be able to see it driving. Depending on live traffic situation now, why couldn't we tell you when exactly are we going to be there? Are we going to be late? The decision to tell someone we're going to be on time or going to be late in itself is a great problem to solve. It's different every day because you need live traffic, you need spatial data, you need to have a lot of likelihoods and probabilities in there, but that's an interesting thing. If you get it wrong, it's quite brand damaging. You don't want to be late and haven't told the customer about it. You don't want to say we are late and then you aren't. Yeah? It's not great either. These things are they're math problems, but they are brand damaging if you get them wrong. They are enhancing the convenience, the speed of what you do, an awful lot beyond any competition if you get them right. Future of this stuff. The good old drones. Are we going to fly drones? Are we going to drive robots? I don't know. But what matters is the speed. You're going to need to be fast because people want some stuff fast. Some stuff you don't need immediately. You want it tomorrow. You want it at an exacting point, or you really don't care. It differs. And for every single use case where it differs, we need to find a different solution for this stuff. And that's where we might fly drones one day. Yeah, who knows? But it's not always about drones. It's also about how do we solve the whole last mile problem in the world. We can't keep adding more and more online shopping to things and not come up with a better solution other than, oh, we drive to your house for every single parcel with a massive vehicle and offload a tiny parcel. That's not how it works. And even that long-term strategic stuff, which is to a very large extent, again, very analytical, very technical, is something we have to solve over the next few years. But it's not a million miles away. If you've ever seen a Google car driving around, and anybody fortunate enough to drive a Tesla or have driven a Tesla? No 150,000 pound cars. They're awesome pieces of kit. They're auto-driving, they're doing that themselves. They drive you home with other than sitting in the car, you don't have to do anything. They look your calendar up and drive you to the next thing in your diary. That kind of stuff we have to figure out. We don't know that yet, but that's a pretty cool journey in order to just being a grocer. So yeah, that's what I do. I'll make people happy. Thank you very much.